Okay. This time we're going to do looking at optimizing perimeter and area with a rectangle. But this time we're given a set area. So you got to get a certain amount of space. So we got a bit of an example here. We can put fencing that's 2 meters by 24. And we can check, does this work? Well, we remember our area for a rectangle is length times width. Okay. We'll call this our length and this our width. And it doesn't matter. We can reverse the order or you'll still get the same answer. In that case, we have 24 multiplied by 2, which gives us 48 meters squared. Great, that checks out. We got that. Let's take a look at a perimeter. We're trying to minimize perimeter now. We want that to be as small as possible. Well, perimeter is the addition of everything. Now, there's this little formula that we can go 2 times L plus W, and that will give us our perimeter. Instead of adding up all 4 sides, we can just add up 2 of them and multiply by 2. So 2 times, we said the length was 24, and the width was 2. We do carry out our bed mass. 24 plus 2 gives us 26. And then we still have to multiply by 2. So that gives us 52 meters. All right, that's a lot of fencing, 52 meters, to get 48 meters squared. Let's see if we can't make this a little better. In order to make it something better, we need to create another area of 48. So I'm going to make something that's maybe less extreme. Oops, let's see if they're a little closer in size here. We'll try something like this. Okay, let's see. And I'm going to say, I got to think of some factors of 48. Okay, factors of 48, 12 goes in, 6 goes in. Let's try 6. 6 times something. Well, I can quickly check this by going, that's a division there. How many times does 6 go into 48? I can try my multiplication table. 6 times 5 is 30, times 6 is 36, 7 is 42, 8. It goes in 8 times. So if I do 6 and 8 in terms of their lengths, I can check out the area. And we can go 6 times 8, and that gives us 48 meters squared. Perfect. That checks out. We're within our constraint for area. So we have to do that every single time. We have to make sure that our length and our width, when multiplied by each other, equal 48. Next, we check the perimeter. We take that perimeter formula, and we know it's got to be length plus width. I'm going to see if we can get a smaller perimeter here. Our length, we're going to say, is 8, and our width is 6. So we'll go 8 plus 6. If we carry out our bed mass, 8 plus 6 gives us 14. And then 2 times 14 is 28 meters. Oh, that is significantly less than 52. That one works out really, really nicely. Can we get something even better? Now, I alluded to this in the other one. Can we build a square out of this? Let's see if we can't build a square. Now, these aren't to scale, because obviously my areas are changing. I'm just trying to make a square here at this point. So we remember, for our square, I need area, and to make a square, these 2 sides have to be the same length. So this one's a little trickier. Well, I know my area is going to be equal to length times width, but in this case, the length and the width are going to be equal. Okay? So in other words, I'm going to have something like this. Length squared is equal to the area. Now, our constraint for area was 48. So we have to isolate for L. So this may not have been an operation you've done before. But if you have a squared, the opposite operation is the square root. So we have to take the square root of both sides here. Now when we do this, this cancels out the squared, and we end up with just the letter L. But square root 48 is a number, but it's probably not a very nice number. If we quickly will grab a calculator on the side here. Let's do our square root of 48. Square root of 48. I assume I'm going to get, oh yeah, this long repeating decimal. Okay, well, let's put it in. We're going to say it's about 6.9282, and then it goes 0. Technically it goes longer. We're going to say it's approximately that in length. Not a lovely number. Hopefully they give us some nicer numbers to work with. So in other words, what we're saying is this distance here is 6.9282. Luckily, we're going to keep a calculator handy. On 6.9282. Okay, let's test this again. Area. We need to do 6.9282 times 6.9282. So we test that on our calculator. 6.9282 times 6.9282. That gives us almost 48. 47.9990. way through. So we'll just say it's approximately 48. Okay, now I know we're off by a little here, but this is to show the point of what we're trying to do. Okay, so we'll say that pretty much checks out. If that checks out, the perimeter, we just got to add this number 4 different times because it's a rectangle. Now, instead of just adding it 4 different times, because all the side lengths are the same, this is a really unique perimeter. This perimeter is the side plus the side plus the side plus the side. And we already know the side is 6.928, but all the sides are the same. So instead of adding it 4 different times, I can just multiply the number by 4, 6.9282. So we'll do the same thing. We'll take out our calculator, 6.9282, and we'll multiply by 4. That gives us 27.7128, okay, in terms of meters. Now, doesn't look like a big difference, but again, the point of this is to show that 27.7, that is technically less than 28. As we went from an extreme to a more square-like object to the exact square-like object, our perimeter shrunk. Okay, so if we have a constraint of an area and we turn it into a square, we minimize the perimeter. And the opposite of that, if we had a constraint of a perimeter and we turn it into a square, we maximize the area. Okay, squares are these really unique shapes that help us minimize perimeter and maximize area.